Okay, now this is the big deal. We can write this as a matrix equation where, well, here's a matrix equation, right? This equation tells us if we have the definition, and you asked about that, and that was very good, okay? Q1, Q2 prime is Q1 prime, Q2 prime. It's just a vector function. And since you've had multivariable calculus, not everybody that might watch this video has had the vector calculus, okay? But it's just vector calculus, definition of derivative, okay, of a vector function. That could be Q1i plus Q2j, where I and j are the unit vectors. And you could extend it to any dimension, okay? So you should be comfortable with that notation. But I think you are, since you asked the question, since I defined it for you, okay? Well, this is of the form x prime equals ax, where x is your Q1, Q2, and A is this matrix. Right? Now to solve the equation, we're going to assume, big deal, first of all, you're familiar, you're used to using e to the RT or whatever. We're going to use e to the lambda t here, okay? Because we're going to end up finding eigenvalues and eigenvectors, okay? And very easy, because we're probably not going to go past 2 or 3 dimensions, okay? You get e to the lambda t multiplied by some vector that I'll just call A, B. Okay? And then we've got to figure out what this vector might be. And that's where eigenvalues are going to come in. Because x prime becomes leave myself room to get around that arrow. Okay. Left-hand side just becomes lambda e to the lambda t times your AB vector, right? And that's going to equal your matrix times e to the lambda t times your AB vector. Okay? So that skipping a step that you should understand. Maybe leave myself room to write what I need to write. Matrix A minus lambda I I want to write that. I've been writing a lot of fractions for calculus. Gives you this. And we might refresh you a little bit in linear algebra, fill in a couple of holes here. And that's just your eigenvalue equation.
Yeah.
Okay?
I don't see how that relates to the previous step, though.
This is just, this, sorry, is just lambda e to the lambda t multiplied by I times the AB vector. The e to the lambda t divides out, and then we use matrix properties to show this is just a minus lambda I times the AB vector has to equal the 0 vector. I'll write it out in more detail. Okay? Because that's a step you got to understand, and you're not necessarily going to remember it. You did it in linear algebra. It's been over a year. Okay? So we need a little refresher, but once you've seen it, my experience is that differential equation students also always pick this up very, very, very quickly after having had the linear algebra. Okay? So we'll do that.